Okay, so we're going to be going over the 2009 AS Pure Maths paper that you can see here, and we're just going to get started straight away. So I'm going to do this in three parts. The first part is going to cover questions 1 to 5, and then I'll do 6 to 10 and 11 to 15. So in the first question, it says that the line L1 has this particular equation, and L2 has this equation here where we don't know what the gradient is. The first thing that it says is that these two lines are perpendicular to each other, so we know something about them. First of all, I'm going to find out the gradient of line 1. So for the gradient of line 1, I'm going to rearrange this so that I make y the subject to find out what the coefficient of x is. So I would get 4y equals minus 2x plus 3, and then I will divide by 4 so that I get minus 2 over 4x plus 3 over 4. So you can see here, when I simplify this, that I get minus a half x plus 3/4. So the gradient of line 1 is minus a half because of this value that I've got here. So the gradient of line 2, because it's perpendicular, is going to be the negative reciprocal of minus a half, which is just going to be 2. So that is the answer to our first question for part A. For part B of the question, it says that they meet at the point P. So I've got these two equations. The first line is 2x plus 4y minus 3 equals 0. And our second line is y equals mx plus 7. But we've just worked out that m is 2, so it will be 2x plus 7. If they're going to be meeting at the particular point P, that means solve simultaneous equations. So I'm going to solve these two equations that I've got written here and here simultaneously, and the best method of doing that is substitution, because I already have y as the subject of this equation. So I'm going to substitute number 1 into number 2. So that would give me 2x plus 4 lots of y, which is 2x plus 7, minus 3 equals 0. Expanding the brackets, I get 8x plus 28 minus 3 equals 0. And so this simplifies to 10x equals minus 25, which means that x is minus 2.5, or you may have written it as minus 5 over 2. Now you'll notice here it only wanted us to find the x coordinate of P. This means you don't need to find out what the y coordinate, so our answer of minus 2.5 is good enough for us to stop here. So I'm just going to compare this to the mark scheme. So for the first part here, you can see that we've got the gradient as 2, and for the second part we see that x is equal to minus 2.5. Pretty simple for the first question that we have there. Okay, I'm going to go down to question 2 now. This one was a bit tricky, and some of my students found this one a bit more challenging. So first thing I want us to notice here is it says find using algebra. This means you can't use your calculator to solve these equations. You'll also notice that we've got part 1 and part 2. If it said part A and part B, then they would be linked to each other, but these ones mean that they are not actually linked to each other. Now there's many ways of solving this equation, but I'm going to go with the way that I would probably think about this. First of all, I can see that I could divide both sides by 2 to get rid of this 2 that I've got here, which would give me 8a squared equals the square root of a. Now, many people don't like dealing with square roots, so there's an option of what I can do here is I can square both sides, which would then give me, making sure you square each term individually, 8 squared is 64. A squared all squared is a to the power of 4, and when I square this side, I just get a. Now you have to be careful here, because if you don't recognize that there is a solution that a is equal to 0, because obviously 64 times 0 to the power of 4 is equal to 0, then you're going to lose a mark. But I'm going to show you the way that you can make sure you don't lose this mark. So what I'm going to do is I'm going to put it all onto one side so that it looks like this. And then I'm going to try and solve this equation by factorizing. So if I take out a factor of a, I would have 64a cubed minus 1 equals 0. So this means two different things. Either a is equal to 0, or 64a cubed minus 1 is equal to 0. When I solve this equation, I get 64a cubed is equal to 1. A cubed is equal to 1 over 64, And so a is going to be the cubed root of 1 over 64. Now you can probably do this without a calculator, but I'll just show you what it would be with a calculator. So I'm going to do the cube root of 1 over 64, which is just simply a quarter. So we have two solutions here. We have either a equals 0 or a is equal to a quarter. Now, you may like to see an alternative way that you could have done this question, and this could actually be done using powers as well. So I have 16a squared equals 2, and instead of a to square root of a, I'm going to say a to the half like this. Now, if you'd like to, you can still divide both sides by 2, so you have 8a squared equals a to the half. And then you could again bring over to one side, so we have 8a squared minus a to the half equals 0. And then you could factorize, so you could take out a factor of a to the half, which would leave me with 8. Now, careful here, because you need to think, what power do you multiply a to the half by to get a squared? So it's actually 2 minus a half, which is 3 over 2. If you think about what would happen when you would multiply these parts together, you would have a half plus 3 over 2, which is the squared part that you would have here. And that would be minus 1 equals 0. So you either get that a to the half is equal to 0, in other words, a is equal to 0, or you have that 8a to the 3 over 2 minus 1 is equal to 0. Rearranging this is 8 3 over 2 equals an eighth. And people got really stuck here. Now, because of the square root part that you've got here, you could square both sides of this equation. Now, if you square the left-hand side, you get a cubed. And if you square the right-hand side, you get 1 over 64, which then leaves us at the stage that we had over here. So we're going to come up with this same answer of a equals a quarter. Now, I'm just going to go back to the mark scheme here because there are some other ways that you could answer this question as well. So one of the ways they did this was similar to what we did on the first bit, where you have that a to the 3 over 2, it's an eighth. So you do have to get the fact that a over 2 is a solution. They've not done it with the squaring. I think the way that we did it was probably a little bit easier. Okay, let's have a look at part 2 of this question. So part 2 of the question says that b to the power of 4 plus 7b squared minus 18 equals 0. Now, I call these things pseudo-quadratics because it isn't a quadratic, but it looks a bit like a quadratic. So there's a couple of ways you can do this. I'm going to do both of the methods. The first way you could do this is you could use a substitution. And so I am going to let y equal b squared. Well, if y is b squared, then y squared is b to the power of 4. This is just squaring both sides here. So if I substitute into the equation that I've got at the top here, I would have y squared plus 7y minus 18 equals 0. And I'm going to try and solve this equation, which would be y plus 9, y minus 2 equals 0. And when I continue solving this, I either have that y is equal to minus 9 or y is equal to 2. But remember, the equation actually wants us to solve what b is, not what y is, so we need to go a bit further. We're going to use the substitution that y is equal to b squared. So I've got that b squared is equal to minus 9, but this has no solutions unless you use imaginary numbers, but the question says real solutions. And for this bit, we get that b squared is equal to 2, so b would be equal to the square root of 2, but remember you get the plus and minus versions of that you would have there. Some people forgot to do the negative square root, so they lost a mark. Now, the alternative way of solving this equation is actually just to go straight in with factorizing, which some of my students actually did. Some of you may recognize that this can factorize immediately to b squared plus 9 and b squared minus 2, then giving you the same parts of b squared being equal to minus 9 or b squared being equal to 2, leading you to the same solutions that we have down here. So the only solutions we were looking for here was plus and minus root 2. And again, you can see in the mark scheme, we've done exactly the same thing that they have done and how they wanted to have square root of 2 and the negative square root of 2 only for that one. Okay, so we're going to have a look now at question 3. Now, question 3 is some stuff to do with integration, and just need to remind yourself with integration that the first thing you do is you increase the power, and the second thing you do is you divide by the new power. Some people forgot to do that in my groups. and it must be done in this order. So for my first question, where I'm integrating 4 over x cubed plus kx dx, what I'm probably going to do is rewrite this so that I have 4x to the minus 3 plus kx with respect to x. So I'm just going to start doing this. I'm going to increase the power. So from minus 3, it's going to increase to minus 2, and I'm going to divide by that new power. Don't worry about the k, but for the x, I'm going to increase the power to squared, and I'm going to divide by the new power. Don't forget to do plus c. There is a mark that is reserved for that. So I'm just going to simplify this. 4 over minus 2 is minus 2. So it's minus 2x to the minus 2 plus a half k, or k over 2, x squared plus c. Some of you may have written this as minus 2 over x squared plus a half k x squared plus c. Either of these two forms that I've written here and here would be completely acceptable. Now, part B of the question says, hence, find the value of k such that the integral of the thing we were just looking at here between 0.5 and 2 is equal to 8. So I'm going to work on this left-hand side. I'm actually going to work on what is the integral between 2 and 0.5 of 4 over x cubed plus kx dx. Well, I've already worked out in the previous question that the bit in brackets is going to integrate to minus 2 over x squared plus a half k x squared. But I don't need to do the plus c because I've got some limits now, which is between 0.5 and 2. So I'm actually just going to do the substitution in here. So I'm going to substitute in the 2. So that's going to be minus 2 over 2 squared plus a half k times 2 squared. And that, from that, I'm going to subtract minus 2 over 0.5 squared plus a half times k times 0.5 squared. So I'm just going to do this nice and slowly, okay? I have got for the first part minus 2 divided by 2 squared, which is minus a half. And then I've got a half multiplied by k multiplied by 2 squared, which is just 2k. And then for the next part, I've got a negative and a negative, so it's definitely going to be a positive. And it is 2 divided by 0.5 squared, which is 8. And again, I've now got a negative and a positive, so it's going to be a negative here. I've got a half times 0.5 squared. So that's a half times 0.5 squared, which is an eighth. So I'm going to just simplify this. So I have that, oh, not an eighth, sorry, it's an eighth k. Don't forget that there was a k there. So I'm just going to simplify this by doing the minus a half plus 8, which is 15 over 2. And then I've got 2k minus 1/8, which is positive 15 over 8k. Now the question told me that this left-hand side here was equal to 8. So that must mean that 15 over 2 plus 15 over 8k is equal to 8. So I'm going to solve this equation by doing 8 minus 15 over 2, which is a half. And I have 15 over 8k. So I'm going to get my half there, I'm going to multiply it by 8, and I'm going to divide it by 15, so that k is equal to 4 over 15. I'm just going to confirm that is the correct answer here. So for the next question, we've got, you get a method mark for part A for knowing that you increase the power, and you get the 2 accuracy marks for coming up with the full correct statement. And for part B of the question, you get 1 mark for knowing how to do the substitution, a method mark for coming up with an equation and making it equal 8, and then the final accuracy mark for getting 4 over 15. Okay, let's continue now to question 4. I wonder if many of you spotted what this question was about when you first saw this. This says that a tree was planted in the ground. Its height, h meters, was measured t years after planting. 3 years after planting, the height of the tree was 2.35 meters, and 6 years after planting, it was 3.2 meters. And it says using a linear model. Now, linear model means that it is going to be a straight line model. In other words, we're going to be doing linear graphs. and it wants us to find an equation linking h with t. Now, if I was going to imagine this as a graph, I would plot along the bottom the time, and up the side I would plot the height. And it's told me that 3 years after planting, the height was 2.35. And 6 years after planting, the height was 3.28. And we want to find a linear model, an equation that links h with t. In other words, we're going to try and find an equation of a line through these 2 points. Now, normally we would say that it's x along the bottom and y along the side. So that might be helpful for us later on. Now, to find an equation of a line, we need 2 things. 1, we need the gradient, and 2, we need a point. Well, the 2 points that I'm dealing with here have a t or x coordinate of 3 and the y coordinate or an h coordinate of 2.35, and the other one is 6 and 3.28. So first of all, I'm going to find out the gradient by doing the change in the h, or the change in y here, which is 3.28 minus 2.35, divided by the change in the x, which is 6 minus 3. So the numerator will be 3.28 minus 2.35, which is 0.93, and 6 minus 3 is 3. So I'm just going to get that answer and divide it by 3, which is 0.31. So that means that the gradient of the line is 0.31. Now I've got a point. In fact, I've got 2 points. I've either got this point or this point here. So I'm just going to use my equation, y minus y1 equals m brackets x minus x1. But mine's going to be a bit different, because instead of it being a y, it is an h. And my y1 is going to be either the 2.35 or the 3.28. I'm just going to use this one here. So I'm going to subtract 2.35. M is 0.31. And instead of it being an x, x is actually going to be t in this case. So it is going to be t minus, remember I'm using this first coordinate, which is 3. Just going to do a bit of rearranging to make it look a little bit neater. So I get h minus 2.35 equals 0.31t minus 0.31 times 3 is 0.93. Just finishing solving this, I get 0.31t, and I'm going to do here negative 0.93 plus 2.35, which is 1.42. So here we have an equation that links the height of the tree with how many years it's been planted for. Now, part B of the question says explain the height of the tree was approximately 140 centimeters when it was planted. Explain whether or not this fact supports the use of the linear model in part A. Well, it says 140 centimeters when it was planted. In other words, when the time started at 0. So I'm going to use my model for part B with time being equal to 0 to see what height the model would have predicted. Well, the model would have predicted that the height was 1.42. But careful, because the height here is being measured in meters. So it says that the height, according to the model, is 1.42 meters. This is very close to 140 centimeters. So a linear model is appropriate. Is that what I'm saying? Is appropriate and should be so the use of a linear model is supported. If they said that the height of the tree when it was planted was actually 80 centimeters or 100 centimeters, it's not at all close to what the model predicts of it being 1.42 meters. But the fact it's 1.42 meters and 140 centimeters, they're obviously very close to each other. So the model is good. It seems to be a good predictor that it is a linear model and that there is like a constant growth of the plant each year, or the tree each year. So we're going to do now question 5, and then I will stop the video at this point. But this one is nice and quick. So we have a curve with equation y equals 3x squared plus 24 over x. I'm going to write that as 24x to the minus 1 plus 2. And the first thing it wants us to do for part A is just to find out dy by dx in its simplest form. So I'm going to bring the power down. As in multiplying by the new power, and then I'm going to decrease the power by 1. So I'm going to pull this 2 down, so it becomes 3 times 2, and then I have x. I'm going to reduce the power just to 1, so it just becomes 3 times 2x. And then I'm going to have 24. I'm going to pull the power down, so I'm going to multiply it by minus 1, and I'm going to reduce the power by 1, so it goes from minus 1 to 2. And 2 that we have here is just going to differentiate to 0. So I just need to simplify this. 3 times 2 is 6x, and I have minus 24x to the minus 2. And if you wanted to, you could write that as 6x minus 24 over x squared. That's the first part of the question done. The second part of the question says, find the exact range, which means we can't use decimals, of values of x for which the curve is increasing. Now you should know that a curve is increasing if dy by dx is greater than 0. Some definitions say greater than or equal to 0, but both of those, whichever one you use, will still get the marks here. So all I need to do is I have that 6x minus 24 over x squared must be greater than 0. So I'm going to solve this equation. The first thing I'm going to do is try and get rid of this divided by x squared, and I'm going to do that by multiplying by x squared, so that I get 6x cubed minus 24 is greater than 0. I'm going to add the 24 to the right hand side. I'm going to divide by the 6, and then I'm going to take the cube root of both sides so that I get that x is greater than the cube root of 4. Now I realized I didn't go through the mark scheme of the previous one as well, so I'm just going to have a look at that one as well. So for this part that we've got here, you need to use the 2 coordinates, this was from the previous question, to find out the gradient and to find out the intercept. So you come up with this formula of h equals 0.31t plus 142. And so you get the initial height is 1.42 and you get a comparison for the second mark. Then we have, for question 5, the differentiation that we did here. So you get 1 mark for pulling the power down by 1. And you get a second mark for getting, you get two more marks for getting it fully differentiated accurately. And then you'll see in the second part of the question, I said there were 2 ways. You can either have it being greater than or equal to, and the mark scheme will accept either of those for an increasing function. Okay, I'm going to just take a pause of the video here.